Deep learning systems in production. So we keep hearing about deep learning systems. We keep hearing about what people are doing. It's fascinating. There's a lot of research that's happening. But the moment you take it into production, everything goes crazy. Before I go a little deeper and talk about how we're taking deep learning systems into production, I really like this quote from Dave Waters, which shows where we stand with regards to artificial intelligence at this point in time. Now, this is a quick agenda for what I'll be covering today. I'll be literally running through because Steve told me I just have 10 minutes and I can't go beyond that. So we're talking about deep learning microservices. We're going to be speaking about how to containerize them, monitoring the applications and monitoring our clusters, and hopefully with the demo gods, a good demo. Now, deep learning microservices. Microservice architecture has been prevalent for quite some time now, and we've sort of incorporated the whole idea of plug and play of not just applications, traditional applications that we've seen, but also of deep learning modules because we have a lot of them, right? So how do we achieve this? The first thing that we need is to actually have a deep learning module or a model. And in order to do this, we use Keras and TensorFlow to build our models. And TensorFlow right now is probably the most starred project on GitHub. The licenses really help us take things into production a lot easier and also helps us do rapid prototyping. Now, once we have, I can't have a slide deck without memes. And this is basically a funny take on what I really think what happens in the deep learning world. Society thinks, friends think, and then we think we are Jan LeCun, but we're definitely not there, and typically we just import Keras. Okay, so now we have the deep learning models. How do I build them as REST services in a microservice architecture? In comes Flask. Flask is actually started off as an open source. It was a prank by Armin Ronescher for April Fool's Day, where he took a lot of libraries, put them in one single file and said, look at my microservice web framework. But eventually it turned out to be one of the biggest open source projects by Armin Ronescher and his team. And it is this easy to actually bring up REST endpoints. We just have Flask, we build an endpoint, and then voila, it's up. So now, we have models, and then we have a REST endpoint, but we don't really expose in the production world directly as a REST endpoint that can talk outside. So we're using a web server gateway interface called gUnicorn. I don't know how many people are from the Ruby world here, but okay, so it was it's heavily inspired from the Ruby world. What it primarily does is we expose our outside traffic with an Nginx reverse proxy. We have incoming requests coming in. gUnicorn balances multiple app servers that are running on Flask and then responds back with the predictions. Now, we have our models, we have our microservice, and then we have gUnicorn, and then we're done with taking deep learning, building it as a microservice. So now that we have the microservice, we need to look at these containers. So this is something that we normally keep hearing, and especially with us doing a lot of research with deep learning and building models, we say, okay, it works amazing on my system, we have everything that's there, but now it's ops problem because it doesn't really work in production. How do we solve this? So what we're really trying to do is we're taking the idea of microservices, putting them into pockets that we can actually deploy and stop complaining that DevOps didn't do their job. So this is something that we keep hearing, microservices and containers, microservice containers. What really are containers? And containers are not something that's new. Containers are something that's been there amongst us for quite some time, but it took a lot of prominence over the last few years. And the reason being, traditionally people used a lot of VMs. Actually, even we use a few VMs now, but we're trying to move away from it. It's very heavy. It's very hard to manage them. And when things go down, it's really crazy. In comes containers. And containers basically make use of the host OS in a very nice way. It's lightweight, and it basically gives us the capability to spawn hundreds of them without really having to think about a lot of operations. Now, what does containers do? Containers give us the access to portability, they gives us reproducibility and scalability, so which means I can really run the same thing in different environments and expect the same sort of response. You would normally hear when we speak about containers, people think Docker is the only thing that's a container, but it's wrong. There have been containers in the Unix operating system, but Docker is an amazing organization that came forth in 2013 and built enterprise containers. Just to understand the momentum of containers, we have about 3.5 million apps that have been Dockerized. We have 37 billion downloads of Docker containers, and there's been an adoption rate of about 40% of Docker containers. Now, the next question, we have our code, it's in a container, what happens next? We still have the same problems. We have the problem of understanding, okay, how do I deploy? How do I scale? How do I manage? What's happening to my update cycles? And in comes the amazing tool, Kubernetes. So Kubernetes for us really helps in automating our containers, managing our infrastructure, and in the end, basically lets us sleep at peace on the weekends without really having to have a pager and running around to see if our infrastructure is up and if our processes are running right. Now, we have Docker containers, we have Kubernetes, we're basically taking our deep learning microservices and managing our infrastructure. Next. So we've looked at microservices, containers, and we have to talk about why we need to monitor our applications as well as our infrastructure. Logging is very, very important, and it really, really helps us in not just building good applications, but scaling them, monitoring them, and checking what really is happening. Spock too agrees with us. So for us, we've written a lot of all of our services, especially in a microservice architecture. They're running at different paces. They're doing a lot of different things, and it's very important for us to log and not just have logs, but have a way to look and evaluate them. And for this, we're using ELK, and as you can see, there are ELKs stacked on top of each other. So ELK really stands for Elasticsearch, Logstash, and Kibana, which gives us the capability to do real-time search of logs and with a REST API. So what are we really doing? We have logs coming from our various applications. We're using a Logstash forwarder to really forward these logs to an Elasticsearch server. We index it, and then we use Kibana to visualize it, right? And in the end, we have a dashboard that looks like this, where we can look at our traffic, we can look at our logs, what's failing, what's not, set up alerts based on the same thing. Now, we have application logs, but we still don't know what's happening in our infrastructure. And yes, we have more event logs. And how we be managing event logs, especially with Kubernetes, is we're using this open source system called Prometheus. It came out of the open source thing from SoundCloud. So SoundCloud was really managing a lot of clusters and microservices. So when they took the decision to really move from their architecture to microservice architecture, the biggest challenge that they had was monitoring hundreds and thousands of microservices. So they started Prometheus, which basically logs on to Kubernetes clusters. There are multiple different ways it can talk to our Kubernetes APIs, and it basically pulls the state of the infrastructure at any given point in time and pushes this information onto an expressive browser called Grafana. And the cooler part about this is not just having to look at what these logs mean, but it also gives us a lot of help in setting up alert systems when something's not operational, something's gone down, and also helps us to evaluate how much of a size of a cluster we need, how much of memory and CPU we need to run our clusters. This is what the infrastructure logs look like. We know that our cluster is being used for 36%, what are our pods running, and how our entire cluster is behaving at any given point in time. So we have ELK, we have Prometheus, and we're using this to monitor our applications and clusters. Okay, so now we have a demo, and let us all take a second to pray to the demo gods and see if everything looks fine. Unfortunately, I couldn't have my system here, so I have Karthik, who's upstairs, I hope, who's going to actually shift to the demo screen now. Okay, perfect. This is a tensor board, and for all of you who've been working with TensorFlow or with Keras and writing callbacks, this is what our current model looks like. We've taken documents, we're classifying them, and as you can see, we're using a model name called Alpha, right? Christopher, who's in the audience, he's there back there. He walked up to me in the morning today and he said, okay, we have a better model. I love Christopher, but I don't really trust the results until I see it. Now, with the way we've put together our systems, at certain point in time, it should become easier for us to actually push this model and look at the results without really having to write any code. So can we do this? Talk to model deployment.
Sorry, I don't understand.
Of course. Talk to model deployment.
Here's what I found.
Okay, so this is basically Google toying with me, but just give. Talk to model deployment.
Sure, here's the test version of model deployment.
Greetings.
Deploy model beta.
Successfully deployed beta.
So you can see that our Kubernetes cluster hopefully goes down. Yeah, we have a pod that's running. It went down. There's a new pod that's come up. It's going to deploy the latest model that's there in our model versioning system. And when TensorBoard comes up, we have the beta model in production, and Christopher was really right. So we can see that for at least some of the examples where the model was performing poorly, it actually does a fantastic job. Okay, that's it from my end today. And if there are any questions, I would be more than happy to answer. Thank you.